Hey everyone, welcome to BP Coding. Today we are going to learn something really important, how to implement stack using linked list. But before we jump into coding, we need to understand what is a linked list and why we use it. So stay with me till the end. So let's get started. So at the first, what is linked list? So giving an complete overview, what is linked list is? Linked list is a collection of node where each node is pointing to another node by storing the address of the node. So what does it mean? Just give you an example. Like in linked list, this is called a node. As in the node, there is a two part. One part is info and another one is link. As in info part, we are storing our actual data. Like we can store anything, integer values, string values, floating point number, anything we want. And in the link part, we are storing the address of another node which we want to point in this node. Like in linked list, we are pointing to another node. As in second picture, as you can see, at this 355 addressing node, we are pointing to 900 addressing node. Like we are storing at the first data, and in the second one we are storing the address, as this 900 is as address. So linked list, at the first, in the beginning, we have to create an start integer which is pointing to the first node, and at the last of the node we have point null. As we don't know what the further is, and if we want, then we can further extend it by using coding. Like at the last there is a null pointer, and at the first is pointing to first node, like a start is pointing to first node. So this is the linked list, and giving a complete overview why we use linked list over an array. Like array is the traditional method which we can store for storing like integer values, strings, floating point number, and anything. But linked list gives an special features like uh, dynamic size. What does it mean? Like in program runtime, we can manually, like in program runtime, user can dynamically increase the array size. As in the array we have the fixed size, so we don't have access to increase the size of an array. But in linked list we have the advantage, we can easily increase the size of an array in a program runtime. Easy insertion and deletion, like in this note, as you can see, efficient insertion deletion. It means we can easily delete our item, remove it, and insert it in our array. This is it. Like this is the proper overview what is the linked list is. So now let's further deep dive into it. Our main theme is implementation of stack using linked list. So we already know what is the linked list is. Now let's further deep dive into it. What is an stack? So as you can say in the second note, so what is stack? Imagine you have a stack of plates in your kitchen. When you add new plate, you place in on top. And when you need a plate, you take the top one first. You cannot take the plate from the middle or the bottom without removing the top ones. This is exactly how stack was in a programming. Like linked list is a way how data is stored in a main memory, and stack method is a concept how we are manipulating that data, like insertion, deletion, etc. operation. Just like that, linked list is a concept how we are storing data, and the stack is how we are performing action with that data. And as you can see in the example how the linked list is worked in programming, at the first there is an empty stack, and when we push an element, then it's filled at the first position, and when we push the b, then it goes in second position, but it's going at the top, not from the more middle or the bottom. It's going at from the top, just like d, it's going at the top. And when we pop the element, pop means removing the element, then it's removed from the top, not from middle, not from the bottom. It's only we can implement like add data in stack or remove data from the top only. At the first we are adding a, then b, then C, then D. As you can see, our all elements are going stack by stack, like step by steps, one level up, like that. And when we remove the data, like popping, so popping D, C is popping from the top. This is exactly how it works. So stack, this is how stacks works in a programming. As you can see, it's following the LIFO method, like last in first out. As we can see, we are last in last. D element is pushed in our stack, then we are only able to pop out D element. As you can see, this follows LIFO method, last in first out data structure. So as you can see, this is the basic overview what is the stack and what is the linked list is. So now let's further jump into coding. Now let me write the code first, then I'll explain you step by steps how it's working. So let's get it. So in this lecture we are going to study this basic concept of stack using linked list. So at the first way we are studying these features. So basically, in a traditional array method, what operation we can perform in it, like just we can insert element, delete element, update element, and just like that we have to implement that features in our stack using linked list. So this is what we are doing. So at the first, we are including, this is a basic, we are including our this implementation in C language. You can implement whatever you want in any language. This is just a concept. So at the first, we'll create a node. As I already told you, in a linked list there is the two part. At the first there is a data, and at the second there is the link part. And in the data we are storing at the actual data, and in the link part we are pointing to the next node. So this is what we are doing. This is just a basic structure of a node, as you can see in the comment part, basic structure of a node. And at the second line, struct node star struct node star top equals to null. So why we write like this, how it's working? So in programming language, how we can implement the stack implementation using linked list. So let me give you a complete example, so how we can implementing it. So this is the complete overview how it's working. At the first, our top must be null and whenever we add something in our data, means stack, we are pointing that top variable to the first one, like this is top, and whenever we are adding that element we are pointing to the top element. At the first, top is null, and whenever we add something in our stack, then that top will be point to that element. Just an example, at the first, top is null. Whenever we add some element, suppose we added 5, so now top is pointing to the fifth, and the second part there is a null, as null part is pointing to nothing. It means the next part is empty. And at the second, whenever we push other element, we are pointing top to that element, like push 10, then top is pointing to that 10 element, and this 10 is pointing to 5, that previous element. Just like that for 15, now top is pointing to 15, and 15 is pointing to 10, and 10 is pointing to 5, and at the last there is a null. It means it's pointing for nothing. And just like pushing 20, as you can see, top is pointing to 20 and 20 is pointing to 15, and this 15 node is pointing to 10. Now 10, this node is pointing to this 5th node. And now how we can implement this pop method? It means how we can remove it. So this is a concept of last in first out method. So as you can see, when we pop, it means removing element. We can only able to remove element from the top. It means we can remove the element from the backward, from the middle, but just it is an implementation, it is a concept. That's why we have to follow these concepts, like we have to only remove it from the top and insert it from the top. Just like that we are removing. So removing pop 20, so now top is pointing to 15 and just like that popping 15. So now our top is pointing to 10th element, and just like that push 30. As you can see, our 30 is pushing to at the top. Now top is pointing to 30, 30 node is pointing to this 10th. Now 10th node is pointing to last node, and just like that popping 30. So it's only popping out from the top and pushing out from the top. It means we can only implement it from the top, like removing element from the top, adding element at the top. This is a concept, we have to must follow it. So this is it. So in the code, this is what we are doing. At the first we have to write the code for it. At the first, our top is null, so we are pointing our top is null, and this function we are implementing. So let me write down the code at first, then I'll explain you how it's working from the beginning. So this is how our programming is working. So let me first explain you how our main function is working. At the first, we are wrapping everything in our loop function, like until or unless if user click 5, then only we exit from our program, or if not, then run our program infinitely. Like at the first we are giving the options. At the first, push, pop, display, check if empty or not, or 5 for exit. And at the last we are taking input from the user and storing it this choice variable, and we are giving this in switch case, like if user pressed 1, then we have to perform this task, and if press 2, then perform this task, and if press 3, then perform this, just like that another tasks. So let me explain you first how our push function is working. Like push means how we are adding our data in a stack. So let me first explain you. At the first, when the program run, this option appears, and when user press number 1 in their keyboard, then this part will work. This case 1, let me check. Yes, this part will work. So in this part, what we are actually doing is we are asking for an integer value from the user, and after asking that value, we are storing that value in this value variable which we already declared at the top, and that value we are passing in this push function. So basically, whenever user press 1, then we are taking input from the user, and that passing that input value into this push function. So what we are performing in that push function, so let me explain you. So let's go to the push function. So push function, we are accepting an input value, like I already told you. Whenever user press that input option, then program asks for a value from the user, and whenever user enter that value, these values come at this function. So now at the first line, we can basically understand this just for a concept what we have to do. So if we are creating a new node, like if we want to insert a new value, then we have to create a new node. So how we can do that? So just as you can see in this code, we are already created a structure of a node. So that is what we needed, and if you want that node, then we can create it just like that, like struct node star new node. This is the basic structure how we can create a new node in a C language. Like now in this variable, like this is new node variable. In this variable we can store that info part and the value part and whatever part we are declared in the structure. So basically you can understand it like this. In this line we are creating a structure of a node. It means we are creating a variable of a node. Like in this variable we are storing that actual data. So what this function is doing, at the first we are created a variable. In that variable we have to create and store the actual data, then we have to point it out to another variable. So at the first we created a variable, and after that now we created a variable but now this variable is null. We haven't stored anything in it. So in the next line we are adding value to that variable, like new node. Inside new node we are pointing out to data variable, and in that part in this part we are storing the value what we are asked from the user in a previous input, like what we are taking this function, like what value is passed, this value is stored in that variable, like stocked inside stock node we are storing that data in this part, in data part, this part, like new node, inside the new node we are pointing out to data variable, and in that part we are storing our actual user's input. Now our first part is completed. This is what we are doing at the first part. In this info part we successfully created this info node and we stored our actual data in this info part. Now secondly we have to store like point the another node in this node. So how we can do that? So let's see in the code. So at the next line we are checking is if empty. Like what does it mean? So at the first let me explain you. Whenever we come in this line we are checking an condition. In this condition there is a function is calling like is empty. In this function we are checking if our stack is empty or not. If stack is empty, let me clear it out. If stack is empty then return it's true, and if not then returns 0. Return 0. Return 0. Like this function checks if our stack is empty or not. If stack is empty then it returns true, and if not then it returns false. So this is what we are doing, checking if stack is empty or not. It at the first check if is empty or not. So it's if is stack our is empty then we are pointing our link to null, like we are pointing this value. We have to store this, we have to link our next node in this part. So we are checking if our node is empty or not. If empty then store null, if not then point out to top. So as I already told you in the example, like this, if empty then top will point to the first, and if not then point to top this one, this one. So if our stack is empty then point out to null, and if not then point out to top, and after that we are top equals to new node. Like in every condition we have to point this top variable to latest inserted node. So exactly what we are doing in this line, top is equals to new node. So let me just give you an overview how this function is working. At the first we are taking an input from the user, and at the second line we have created an node. We are successfully created a node, like we haven't stored anything in it but we successfully created a node. Now after that we have to store that value and the link part. So in this line we are storing the actual value we want to store in our linked list. So this is the line where we are storing the actual data, and after that in this line we are storing this, pointing that node to next node. Like if stack is empty then point out to null, and if not then pointer to this top one variable, top one node. This is the words concept, and at the last top is pointing out to new node. This is what is working. And talking about the is empty function, this function basically checks if top equals to null then return 1 else 0. It means it basically checks if our stack is null, if our stack is empty then return true, and if not then return 0. Like if our stack is null then it return true, and if not then it returns false. So now let me explain you how our display function is working. So just a second. Now let me explain you how this display function works. Suppose if user press this number 3 option, then how it's working, like whenever user clicks at the fourth function, then at the first it checks if our stack is empty or not. If empty then it's print stack is empty, don't do further steps, and if not, if our stack is not empty then we have to call it. Let me write like this. If not, then display function will be called. So like that, as if our stack is empty, then printf stack is empty, and if not, then it goes to this function, display function. So what we are doing in this function, so let me explain you step by step. So at the first, we display means we have to traverse our linked list from the uh, top and at the last. So how we can do that? So we have to use a loop. Like at the first, we are creating a temp node. Like we are creating a basic temp node, and in that temp node, that temp is pointing out to top node. At the first, we created a temp variable, and in that temp variable we stored a top node. Like top node is pointing to every variable. Whenever we insert a new node, then top is pointing to that variable. So we created a top temp variable, and temp is pointing to top. Now we use a loop, like while loop, and whenever temp is not equals to null, like this loop will run until or unless our all data from the temp, it means our all data is not traversed, like printed in our console, until or unless this loop will run. Like let me explain you this condition, but before that let me explain you what this further line is working. Like in this line we are printing out the value of our linked list, like %d, and we are printing this value. This is exactly inside temp. We are printing the data part. Like in this node, as you can see, we are printing this part. Inside the node we are printing the data part. So temp, inside the temp we are printing this data part, and at the next line we are pointing out to next node. Like temp equals to temp to link, like temp is pointing to further links. Like as you can see, we are printing the data, and now our temp node is pointing to on the node. So let me give you an example of how this loop is working. Like what is this condition means. So suppose like temp is not equals to null at the first, it at the first step it checks if our stack is empty or not, else display function, and then until or unless, this checks until or unless our data is retrieving from the variable. Until or unless our data is retrieving from the variable, we are running this loop. This is what is working. Like until or unless this variable are fetching data. So basically you can understand it like this. We are looping this part. We are printing every value. We are printing every value from the top to the last L node. Like we are printing it until or unless our temp is become nulls. So until or unless our temp is null, we are printing these values, like printing the data part, and temp is pointing to further next node. So just give you an overview how this function is working. So at the first we created a basic structure of node, like created a variable temp. As many of you have a question, why we just don't manipulate this top variable. So this is the wrong way. Like if we manipulate this top variable, then we don't have further access to where our actual data is. Like suppose, as you can see in the picture, if we point out and manipulated this top variable, then we don't know at the last where is our top is pointing. We are getting lost in our program. So that's why we created a temporary variable and point that temporary variable to top. Now top equals to temp is equals to top. What is it? And in the loop part we are looping when until or unless our top is not equals to null. Up to that, print that exact value from the tops. like it's traversing next by next, like this part, this part, this part, this part, this part, and printing out every value. This is what display function is working. Now at the last, how does this pop function is working? So let me explain you how this is working. So whenever user clicks on option 2, like a pop means removing element from the top, as we have starting stack is only possible to remove element at the top. So whenever user press 2, then it's called to this condition and pop function is called. Then inside that pop function we are performing these several tasks, like at the first we are creating a temporary variable and checking if our stack is empty or not. This function is checking if our stack is empty or not. If stack is empty, then return, do nothing. If stack is empty, then show a message to the user stack is empty and do nothing, return the function. Else if our stack is not empty, then do further process. So as we already created a temporary node, in that temporary node we are pointing out the top, and top is pointing to top to the link. It means we are doing just like that. This top is pointing to this variable. We are breaking this link part. Now top is pointing to this part, this next link, and this line in the top equals to temp equals to top. In this line we are storing a temporary value. This node, suppose this node we are storing in the temp variable, and in the next line we are pointing out this top into this node. We are breaking this line. It means we can just basically perform the stack pop operation at the top from the stack. That's why we have to break these links, as we are top is pointing to this variable. So this is what it's doing. And temp in temp's link part we are putting null, as we already know about that. There is nothing, we can just remove this line, this is not necessary. Now at the first line we are pointing out temp equals to top. This means this, now temp is pointing out to this top variable. Top means this part. Now in the second line we have to break this link. So we use this line, top equals to top to the link. So we break this line, and at the last free temp, it means delete the temp completely from the stack. This is what is working. So let me give you a complete overview how this function is working. At the first we created a temporary variable struct node start temporary variable, and checked if our stack is empty or not. If our stack is empty, then we don't have to do nothing. Like if stack is empty, then we can't do anything in our stack. That's why we show a message to the user stack is empty and return. And if stack is not empty, then store that top data into temp variable. And after that we have to break the link to the top element. So we are breaking a link, top equals to top to the links, like we are linking this part. And at the last we deleted the temp variable with data. So this is what our code is working. And at the last this is how implementation of stack using linked list. So that's the end of our video. If you want this code, you can visit our site bpcoding.com. I will provide the link in the description. And if you want this code, you can visit it on our website. You can easily get it. Or if you want further details or further guidance in our coding, then you can check out our courses section in our website. Thanks for watching. That is it for today. See you next time.